Any questions from anyone? Those at home and also from here. So okay, chapter 1 and chapter 2 and 3, right? I'm not sure which is your chapter given by your CC. Just prepare 1 to 3. Okay. Including the probability. Chapter 4 is not included. Right?
Chapter 4, no, right? 1, 2, and 3.
Okay, chapter 1, 2, and 3. Okay, I will share my screen first. If I'm not mistaken, we actually covered up to chapter 4, probability distributions. I think we touched binomial. Okay, you can see my screen. If there's no questions, we will start recording. So far for the final exam, any changes? Still face-to-face, right? No news about online, right? Check your information. No, still face-to-face, right? Okay, so just a quick recap what we learned last week, binomial distributions. Before that, I already explained to you why we have probability distribution. Last 2 weeks, we learned about probability, all the rules, right? Addition, multiplication rule, conditional probability, tree diagram, and also the table. After that, in chapter 4, because we have 2 types of distribution of data. Remember in chapter 1, we learned about discrete data and continuous data, right? Because of these 2 different set of data, when we want to measure the distribution of probability, we have to have different type of measurement. The first one, which we learned last week, for discrete data. Remember, discrete data is the data that cannot be in point form. Remember the decimal point must be integer, like number of people, number of chairs, cars, all this must be integer. So we have to use a binomial. Okay, and then it doesn't matter how many events or tries we have, as long as the total of the proportion must equal to 1. Okay, whether it's binomial or normal. For normal, I think last week I mentioned this a bit. In fact, in our chapter 1 and 2, I did discuss with you some of this normal curve, right, with the left tail, right tail, so on. So for today, we are going to cover this normal distribution as well, and the total of this probability from one end to another end, from left to right tail. Okay, because the area below the curve actually represents the probability of each colleague z-score. Right, you learn very soon. The total must always equal to 1. Okay, so for continuous data, it's data that can be measured in point form, like the length, the weight, the height. Okay, so we cannot use binomial for this case. We have to use normal. Right? So this is how we differentiate between when we use binomial and when we use horizontal. Okay, and then how we know whether the question actually testing binomial? I mentioned that we have 4 conditions. You don't need to memorize these 4 conditions. Basically, the most important thing is when we answer the questions, we check if the question mentioned 2 outcomes. Thinking of that, it may not say that 2 outcomes, it just say 20%, what, or 50%, what. Then you know, they give you the success, and then you should know the failure. Remember, we use P and Q. So from there, you know already there are 2 outcomes. Okay, for example, good or bad, boy or girl, defective or non-defective. Okay, tall or short, profit or loss. So this is all the same examples. Can very obviously show there are two outcomes only. So we have to use binomial, right? And as I mentioned, P will be success probability, Q will be failure probability. But be careful of, because if you look at the puzzle questions, some questions they are very tricky one. They don't give you the success probability, because we define P as always success now, right? And then the failure as our Q. But some questions they inverse it. They give you the failure, you have to find the success, which means, remember the formula here? NCX, right? Last week we already used calculator. Try to feel how to get the answer, right? Okay. Then times P, see this is P or X. P is a success rate. Then times Q, 1 minus P is Q, power of M and X. So you have to be very careful. When you do some puzzle equation, they give you the failure instead of success. They give you the failure, which means what? The P become 1 minus Q over 0. A lot of people, they just bluntly, you see the failure also, they treat it as a P. Cannot really. If this is Q, which is 1 minus P, right, this one become P already. Or if you interchange it, let's say the Q is 0.8, we know the P is 0.2, right? Right? Then you put this P here, and this Q will be here. Or you change everything on 1 minus Q, so the power here you just follow. As long as N minus X must follow Q, the P must have a power X. It's up to you. You want to interchange P and Q value, or you change the power. Let's try some questions. Okay. I'm not sure whether we have to include inside or not the class equations. Okay, now for the mean N times P binomial and the variance you learned chapter 2, right? Variance is N times P times Q. So this is a sigma square, and this is your mean, population mean and population variance. And standard deviation, we just take square root here. Now some of these examples, I think we have gone through. So you can see that this is about what? Tossing coin egg 3 times. So you want to get the probability proportion to get 0 hit, 1 hit, 2 times hit, and all the 3 times also. Okay, so you can calculate all the probability, the chances. For example, the chances to get 1 hit out of 3 times you toss is 0.375. The chances to get 3 tosses, very lucky, out of the 3 times also you get 3 hits, 0.125. Okay, so you total up must equal to 9. Okay, now this is your mean, N times P, and standard deviation, square root N times P times Q. Okay, I'm sure this one also will go through. Okay, so this is the example which I mentioned. How we know this is binomial? You never see the word binomial there, right? If you try your tutorial past year, you won't see any word binomial or normal or Poisson. So you say that the probability college student will graduate 0.4. They just tell you one probability. So what is the other probability? They tell you one outcome. One of the outcome is graduate 0.4. So the other outcome is cannot graduate 0.6. So what I mean just now is some question is saying the probability that a college student cannot graduate. This one is can graduate, right? 0.4. So we call it success probability. But if the question mentioned the probability a student cannot graduate is 0.3, what is that? Q or P? You can change that to P, but you must minus from 1 now. Because cannot graduate is usually failure, right? Negative usually is failure. This is 0.3, but your formula is P, right? P, this is a formula P. So you have to take 1 minus 0.3 to get the P, because you know Q is 0.3 now. Okay, we try some questions then you know better. Okay, you can understand better. So out of 5 students, this is your N. And then find the probability, no students, 1 student, at least 1. I mentioned the word at least means what minimum. 1 can be 2, 3, 4, or 5, all of them. Great. So here you have to take a, I mentioned the word before, at least, at most, between, not more than, not less than. So you can put all these words. Make sure you included the correct number. All will be good. So these are the answers we're going through, right? And I just want to highlight the shortcut one. Remember, at least 1 student. The rest of the part A, B, and D no issue. That's the word at least because we know at least 1 is more than 1, right? So we can take 1 student, 2, 3, 4, or 5. If you want to repeat 5 times, you put the formula. It's quite tedious, right? Right, you still can get the answer. Sit down there, do slowly, do carefully, can get the answer. But I actually highlight the shortcut. So anytime when you find that, you have to calculate a few calculations. You can think of a shortcut. So the one of the shortcut is to take complement ruler. You see this in that right? You have 0 to 5 students. Don't forget that 0 is there. 0 means no student graduate. So you want to take from 1 to 5. Instead of counting 1 by 1, 5 times you take whole probability is 1, right? You minus the 0, that means no student graduate. So 1 minus no student graduate actually will give us at least 1 student graduate. This is the shortcut formula. Yeah, so I hope later you do a tutorial or classification. You find the similar one, and then you do your shortcut. Okay. Alright, I'm not sure whether you all have done this. Looking from here, we discuss some of the questions, right? Have you all tried this or you? We didn't go through 1 by 1, right? But you all try already. Can everyone get the answer here? This is a practice. I don't think this example is tough. It says that the chances to sell 1 car is 20%. 0.2. So the Q is 0.8. So this salesperson sell to talk to 5 people. Exactly 3 buy, at most 1 buy. At most means 0 and 1 customer. At most maximum cannot be more than 1. At least 1 customer. So 1, 2, 3, 4, 5. Here. You can take shortcut again. 1 minus nobody buy. You should get an answer. Then fewer than 3. Fewer than 3 means less than 3. Can it be including 3? No. Okay, this is the box I highlighted last week. If you can remember the sign better, fewer than, you see, it's just less than. This is all inequalities. You all learn mathematics, right? More than, less than, equal sign. So these are inequality. Now, fewer than, there's no inclusive, just less than only. So fewer than 3 means what? Less than 3. That means you only can take 0, 1, and 2. 0, 1, and 2. 3 cannot take. Yeah. Those of you including 3, 1, you will get extra value. So your answer will be bigger. Minus 1. Definitely minus 1. Examiner will be very, very strict. So you have to watch out for all these words. It's a strong reminder. Okay, and then more than, no issue. More than means X more than 3. Unless the question says more than or equal, then we'll write more, including 3. Okay. Right. So that is a sign of equities that I want to mention here. Okay, the mean of binomial is also equal to its expected value. Now, this expected value actually is another probability we call it expected value for special distributions. So we're not going to cover in this chapter. Okay. Standard deviation of a probability distribution is a measure of dispersion. Chapter 2a, remember dispersion, spread. How big is your variation? Remember when we talk about CV, coefficients of variation. Okay, when sigma is small, sigma is our standard deviation, right? The probability that we will get a value closer to the mean is higher. And then that means what? Remember when I talked in chapter 2, the smaller the standard deviation, the better the value, right? The smaller the standard deviation is, the value is smaller, which means the spread is smaller. In other words, it's closer to the mean. Okay, remember I talked about this normal curve. I use the normal to explain easier. Now remember the spread from each data to the mean. Do you remember this one? We take 1 by 1 minus the mean. This is the mean, right? So the smaller the standard deviation, which means the closer to the mean. Meaning what? Smaller sigma is what? Smaller variance up. Because variance is what? Square of sigma. Remember? Standard deviation is square of variance. So they are the same one. And then when your variance is smaller, which means the spread is smaller. Spread is smaller. When you say the spread is smaller, that means the distance here is smaller. So in other words, it's closer to the mean. And then the opposite, when the sigma is big, we are more likely to get the value far away from the mean. The spread is bigger, so the distance is bigger. Okay, I hope you remember chapter 2b, measure of dispersions. Right. Okay, so you can do a tutorial for a minute now. Let's go to normal distribution, the second type, which I mentioned. We use it because of the variable is continuous, like height, weight, okay, length, all this one can be measured in point form. Same heights of people. The height of a person is not to be exact. When we measure the height, the weight, no need to be exact number of centimeters, but can be anything within the possible range. Correct enough. Temperature of a room. You have done a lot of experiment during a science school, okay, whatever. When you measure temperature, not necessarily round number, right? Our room temperature is in degrees Celsius. What's the room temperature? Anyone know? You ever study science? Only science, animal also should know one. Can you go and find out or not? Oh, somebody answer already. 29? 27, 29. 27 to 28, 29. Yes, around that. What's our body temperature? 40. 70. 36.7, right? You all measure so many times already, Madhuri MCO, out the temperature. Okay. 36.7. Anything higher than that, you will. Okay, so let's come back to example. The characteristics of a normal distribution. So now officially we enter to this specific curve. A few times I already draw this. Now we officially study the characteristics of a normal distribution. Some of you already learned that if you take your MS, you should be able to expose to this curve, right? So what is so special about this curve? It can measure probability from one end to one end. Okay, and that's so special because of the shape. Very beautiful, like a mountain. Okay, they call it dial shape. In our school bell has come up. Now no more school bell. Use what? Electric bike, right? Silent. Last time, my era always ice cream bell one. As marked as one class finish already, next class coming. Okay, so it's a shape of bell, right? Now it's a symmetry. Symmetry means if you cut this into half up, this is our reflection. Okay, so you see this left and right side, they are actually same. Okay, symmetry. About the central mean. Now the two tails, as I mentioned here, they never touch the axis. Remember, they never touch the axis because this curve, it looks like very near to axis, but it never touch. It never touch. That means no ending. In other words, the two tail no ending on until when we don't know. But we can say this up to infinity. Do you know this symbol, right? Anyone to know this symbol? Yes, right? Infinity, never infinity. So that's what we know. Never ending one. And these are the few characteristics. More to come. Total area under the normal curve always equal to 1. What does that mean? I told you, right, from left to right, the whole thing must equal to 1. So if you look at the table later, might as well we go down now. Everyone, can you scroll down to your table here? Many of you have seen this before. Okay. Now there are 4 versions. If you look at different country, they may use different version of normal distribution. For Malaysia, most common one is used this type. Now some, you see, this is the normal curve, right? You see the shaded area. I'm not sure last time when you do your school last time, are you using this school or using this version or use different version? The shaded one means this is the probability given from one z-score, I explain later, measure to outside. Sometimes different version they give you the negative one. Now when we cut this into half, see this is 0. 0 means this is a mean. The right hand side always positive. Remember symmetry, the left hand side is negative. So whether you look at the positive side or the negative side, doesn't matter one, because of the symmetry now, remember. So later I will explain to you Z and negative Z. So the two values actually is the same. The only difference is one positive, one negative, because of the mean is in the middle. So just remember, this version we are going to use it in our faculty, not only faculty, I think most faculty use this type, measure outside one. Some version they measure inside one, they give you the other way. So you have to take, remember the whole thing is 1, right? Whole thing is 1, you have to minus that, the given one which is inside to get the outside probability. Now we are going to do some exercise onto this. Okay, now you can see this is your z-score here, x minus mean divided by sigma. I explain to you now. Now before that, you can see there's so many 4-digit 0 point. Can you see the point there? Actually, that measures 0 point now. For example, let's say it's 0.1423 means actually 0.1423. All these are probability for each z-score and also the point from here. Now, this table only gives you 2 decimal points, 0.00, 0.01, 0.02, up to 0.09. Actually, we can use up to 4 decimal points now. Remember, the more decimal point, the more accurate. So some textbook and some there's a way to find using interpolation. If the question gives us 4 decimal points now, which is more accurate, actually you can use interpolation. If not, we round it up to 2 decimal points, and from there we find the probability, which is slightly different now. Okay, but we accept that. So these are all the probability. It's meaning that the total area, each z-score right below this curve will be given by the probability here. And then you can see all this probability cannot be more than 1. This is 0 point something. The biggest z-score is, the smallest is from 0, the biggest is 1. 4.0. Cannot be more than 4. And then this is your smallest probability, 0.0003. Almost 0. Okay, now I want to highlight this also. You see, this is half, right? Mean, this is your mean. So half of this probability is given by 0.5. Another half here is 0.5. How do you know? Because we see total was equal to 1. That's why you see, from the mean to the point, that's called 0 here. Right? You see this is 0, which means the mean 0. The probability is 0.5. It's 0.00. And that's called 0, which is the mean here. Probably half here and half here. So we do okay. So coming back to here, you can see this formula actually is to calculate integration. Those of you who learn MS, you know this symbol, MS, integration. Okay, you learn differentiation and integration. So the formula to calculate this area, remember we do calculation, integration, calculate the area right below the curve from one end to one end. See this one, ABT. So this is the formula exponent. I'm not sure how many of you learn exponent about power of this. It's not easy to integrate. It's not easy to integrate. This is a higher advanced calculus. You know what's called calculus, right? Those of you science students. Okay, don't worry. We're not going to test MS here. So those want to try, you can try, but it's not easy, definitely. That's why mathematicians as a message that we come up with this, instead of integrating one by one, the area from one point to one point, they scrap this idea. They change everything, probability here, for each z-score, they come up with this table. So now we don't learn the integration. We straight away pick from the value which the statisticians already calculated. We don't know how they calculate. This table already so many years, it could be 100 years also, we don't know. It's used worldwide one now, not only Malaysia. The whole world is using this. It's a two statisticians who created this normal paper. Alright? If you're interested, I can't remember what's the name now. You can check our website who created normal distribution. Okay. So don't worry about the formula, as I said. We're not going to touch it all. So the normal curve has a single peak. This is the one at the center. Okay. Now the mean, median, and mode. Remember chapter 2a. Mean, median, and mode of the distributions are equal and located at the peak, which means the mean is here, the median is also here, the mode also here, located at the peak. Now, if the mean, median, and mode are shifted, which means if the mean equal to mode equal to median, the values are about the same, then they are actually on the same peak here. Now, we can also, when we do some research, we find that the mean more than the mode, more than the median. What happened? More than then that means the normal curve will be what? Remember in chapter 2, you learned this, what do you call? Start from S. Skew. Do you remember this word? Skewness, chapter 2, right? What does that mean? This one is what? Skew. Positive, this is skew. Negative, right? Remember? Because of the mean, mode, and median is different. If those of you further study one, you learn more about this. But if the mean, mode, and median is about the same, okay, we have a lot of software to help us to calculate one. Then actually they are all located at the same peak there, almost up. And then you can see the left and the right is symmetry. If not, we have skew positive and negative. Okay? The normal distribution, this is the one, is completely specified by two parameters, which is the mean and the standard deviation. And you see the function fx. You all know what's fx, right? Mathematical modern function. Remember your y and your x. This is the fx, right? How many of you don't know? Shouldn't be a model max also have one. So you see that the function is your y, right? Now you see the y, as I mentioned, function of this normal curve is given by this. Very scary, right? 1 over sec 2 pi, you know this like pi times sigma squared times e. E is the exponent function. How many of you learned this before? I don't think so, lah. Form 5 level, not yet. You look at a calculator, right? You look at a calculator, got this button, right? E power x. You see a calculator? I think business faculty students may not learn up to this level. But for science students, yes, those especially those major in calculation and mathematics, they will learn this exponent. Log you learned before, right? Log function, you know. So this is a problem. Exponent function is a very special graph. The graph is like this. The graph is like this. This one, the curve also never, the end here never touch x-axis one. So similar to your normal curve, right? I told you, but the normal curve got like a bell-shaped one because of these equations. So this is your E. Everyone, can you press calculator? Those of you want to know more, so I explain a bit here. You know how to get 2.783? You use your button calculator E power. Square, everyone. Can you press E power 1? You know how to press. Press the shift button. See the shift button. Then E power 1, you get 2.71. Okay, you try E power 2. 7.1. 7.39. 7.39. You see, you try E power 3, 20 point something. That's why you see your curve here getting bigger. And then when your E power 0, mathematics, E power 0 equal to, any E power 0 equal to 1. Anyone to know? E power 0 is 1. That's why it intercept here 1 now. So you see your curve here, where x is 1, 2.71, and E power 2, 7.3, E power 3, 20 point something. You see this curve will up very high. Science student, you study this because of what? Bacteria. You know what's bacteria? Bacteria in our stomach. 1 second grow so much. 1 minute grow so much. Very fast they spread. Same as the COVID, especially Omicron. This is one of the populations of bacteria. So for this exponent, it can grow very fast, but because of this, I believe so. Okay, the curve will come down again, but it won't touch the x-axis. So we end up like this. See, very high one. We don't know how high is this. What your answer is the probability below the curve. So we have this 1 by 1. So instead of finding 1 by 1 any double, as long as from left to right must equal to 1. So last time they call it integrate. That's why for this normal, right, the probability. So that's why they call it integrate this. Sorry, with the dx. I'm sure you all those science students they know this lah. Well, don't worry, for us students, you don't know what anything also they 1 by 1. Because you want to find the area from one side to one side, it's actually fastest way is instead of adding 1 by 1, we integrate. But again, this formula not easy, man, just like I mentioned. So what we do, this is the symbol from one end to one end. Negative infinity to, you see the tail here, you know ending 1. So very hard to integrate. That's why they come up the table just now to represent each z here, z1, z2, Z3, one by one the Z score, they give you the probability, 0 point something. You see how smart these two guys who created this normal curve. I'm not sure how old it is table. It can be many hundred years. Oh, all right. Any questions before I go? You're clear already with this normal? Compared to binomial, nothing much. Yes. Yes, Mukiman. What's your questions? Kiman, are you there? Reply again. What you want to reply? Repeat or what? Reply. Repeat. Kiman, are you there? What you want me to repeat? Not here already. Okay, never mind. We come back to questions. He or her. Okay. So no questions. I go on. Now, if a random variable, let's say height, weight, as I mentioned just now, as a normal distribution with mean, and the standard deviation sigma. Remember, binomial, you have to define your x, right? Remember I mentioned that x defined as what? Then the x distribute as binomial with n and p. Remember this one? You see your notes again now. This one. An example. You must define what's your x, then you write down the distributions. So marks will be given more. 0.5, 0.5. One mark here. Those of you who don't write, still can get two answers, but lose one mark. If you think this one mark not important, then you might not need to write. Okay. One mark is very important. Alright, so for normal, same thing, we have to write let x equal to variable, then your x distribute as normal, write the mean, and your standard deviation squared up. When the standard deviation is squared, this is our variance. Variance, right? Those with the square one is variance. If you don't have a square, means you square it, is your standard deviation. Until now, some people still confuse between the square and those square, between the mu and the x bar. Remember I said you must know the face, you must know the name. The other one, some question they write standard deviation, then you yourself have to square it. Some question mention variance. If you say variance is 9, then what you write? 3 square. Look at the question carefully here. That's why it's square and no square, you must know the difference. Okay, every different combination of mu and sigma will generate a different normal distribution. The shape of the normal curve depends on the value of standard deviation. As I said, a larger standard deviation results a flatter, wider spread distribution. What does that mean? I think I mentioned before, right? If you have a bigger sigma, your normal curve will be what? Flatter. Flatter means what? Wider spread. The left and the right tail are open wide. So this one becomes a flatter. What do you call it by summation? Maybe in flatter. Flat, flat, no flat. What do you call it in Mandarin? Okay, if your sigma is bigger, which means the taller the peak. This one sigma is lower. This one sigma is bigger. So here will be not so wide. So the distance here will be what do you call closer? Okay. So this one, this one is bigger. Shall I write here bigger? Yes, sigma is bigger. Sorry, this one is lower. This one sigma is bigger. I repeat, if your standard deviation is bigger, the spread is bigger, then this one is flatter. If your sigma is lower, this one will be closer, so the spread is lower. This one will be taller. Can you see the difference? And then I also asked you last time, which one is better? This one better or this one better? You want the bigger spread or you want the smaller spread? You want the smaller spread, right? Remember when we learned the CV, coefficients of variance? Saturday is a test, you already, right? What did I say? CV. The bigger the CV, the bigger the spread, higher variance, right? Less consistency. Correct? The valid one now. So in this case, your variance is smaller, the result is more consistent, better. So we want this, the smaller standard deviation means smaller variance. However, standard deviation, okay? We don't want the big spread, we want the smaller spread. This one no good. Okay, you see the picture, this one is taller, this one is better. Okay, so that is the characteristics of normal distributions. I believe I explained already. And then there are also a few things that we can play around with this, we call it dispersions of frequency around the mean, which can be measured exactly in terms of standard deviations. For example, about 68.26% of frequency have a value between mu and plus minus the sigma. So actually, if you know the mean and you know the standard deviation value, the percentage of is about 68.26%. If we take 2 multiply the standard deviation, then this one will become 95%. This is another way where statisticians or researchers they use a shortcut. Like a you know the what do we call in Bahasa Malaysia, we call it CFA. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, but we call that CFA, right? Last time we had this, so they can remember if 2 times mean this one become 95, 3 times this one become 99%. So 99% is almost 100%, very accurate. So that's another way they can remember. But don't worry lah, okay? We don't really memorize all this. Okay, just to explain to you, the dispersion can be actually measured by looking how many times to the standard deviation with the mean no change. Right? Okay. So let's go to our main content now. Just like I mentioned, when you write down the distribution here, you write your mean and your standard deviation square, right? Okay, this is the general form where your mean here is not 0 and your standard deviation is not 1. Remember? So when you have mean not 0 and standard deviation not 1, example, x distributed as normal with 10 and 5 squared. So mean is 10, standard deviation is 5. So in this case, we know mu is 10, sigma is 5. So we call this one non-standard. Right down here, non-standard. And one I want to think of non-standard. As long as mean not 0 and standard deviation not 1 is called non-standard. So that means generally, if you write here any number like mean, sigma, any number, as long as not 0 and not 1, this is called non-standard. Okay. Now, if you have non-standard, you cannot use the table like just now what we have seen here. Remember the table? Why? Because I told you, right? You must change your non-standard to standard so that the mean here is always 0. Can you see the mean in the middle is 0? And the standard deviation always equal to 1. Because if you don't change this is your z-score, your maximum is what? 4, minimum is 0. If you don't change to standard, you will get your value of x can be very big, very, very small. Whereas the z-score only from 0 to 4, remember that. So when we want to use this normal table, what should we do? Change from non-standard to standard. That is to find what? Z-score. We call this thing Z-score. Okay, I go back to formula now. I hope everybody understand now. So non-standard must change to standard. How we know we already reached standard? Use this formula. Okay, any normally distributed set of values can be converted into the standard. Non-standard convert to standard using the z-score, which is x minus mean. X is your data. Remember, we let x equal to minus the mean divided by the value of the standard deviation. Okay. Let's see any questions from those at home. Nobody have any question. Okay, I go on now. Now, as I mentioned, if the random variable x distributed as normal and sigma squared, we need to change to standard using this formula. And now, after you change the standard, you don't write x already. Just now you write what? X distributed as normal. I use x, 10 and 5 square. So I change to standard. Once I change to standard, I don't use x, but I use. So I use the z already. Distribute as normal, and definitely your mean is 0, standard deviation is 1. Can you see the difference? X becomes z. So when we do the equation later on, every time when you change the x by using this formula to z, you must write this way. Once you change the standard, you can use the normal table. Yeah? Alright, so this is your standard normal variable, or we call it standardized normal variable. By determining the z value using the above formula, we can find the area. See, once you change your z-score in standard already, we can find the area of the probability under the normal curve by referring to the normal tables. So you must change your standard first. Baru boleh guna the table. Okay, let's start. So area under the whole curve, as I mentioned just now, from left to right. Doesn't matter how long, doesn't matter how high, as long as the total is 100%. So don't worry about integration, don't worry about the formula. We are not going to use it at all. Can throw away one. But it's good for you to know the equations. Alright? Okay. Now, probability for Z. You see, all these are using Z already, right? Because it's what? We want to use the normal table. So you see, we will use X1, we use Z. Later, we will learn how to change the X to Z. Use the formula just now, right? X minus mean divided by standard deviation. Now, let's play around to understand better. Z more than 0 or less than 0, both also same. As I mentioned the word symmetry, right? Whether they are positive or negative. As I mentioned here, more than 0 means this side. Less than 0 means this side, because this is 0. Right? So the total is always 1. That's why we know each side is 0.51. Okay, next, probability for Z more equal to or value is the same as probability Z more than Z. You see this one for equal sign, this one no equal sign. Example, Z more than equal to 2. This one means including 2, right? You can also write at least that more than 2. Ignore the equal sign. Why? Can I ask you why? So this is what? Continuous. Remember chapter 1 when we do the frequency distribution table? I always very scared when I have to use a lot of example. Remember in the chapter 1 when we use this pass boundary, let's say I have 0x to 1, then 1 here, and then this is 2. Remember the equal sign you can ignore it, right? As well. X and 1 and 2. Equal sign you can actually ignore it. Because of what? Continuous data, remember? Same thing for this normal, you can actually ignore the equal sign. Understand? Example, let's say I use this example, more than 2. Remember 2 is positive, so we must find the 2 here. This is a Z-score 2, 2, so you don't need to look at the equal line. So more than 2 means what? This is the one we shape. Learn how to shape the area first. More than 2. Now, if I want to ask you, can you find the probability for me here? Let's start. Look at the table. More than 2. So let's go down, everyone. There are more to come up. You see all this we can learn. Once you know 1 or 2, you know the rest of it. The concept. Okay, let's say more than 2, everyone. Maybe, sorry, we have to scroll up and down. More than 2 means look at the Z2. Where is it? Here, 2.0. So 0.022. So 5. 0.02275. Everybody okay? Huh? So this one actually. Yes.
Can you explain again?
Oh, you mean the
I don't really understand.
More than 2, more than equal to 2. If you the patient say at least remember we have to put equal sign there. So we actually can write more than 2. Ignore the equal sign. No need to put equal sign also okay one. Because this is what? Continuous data. So for normal, whether you have equal or not equal, there's no difference. And then more than 2 means positive 2 mark. So I told you right hand side is positive, left hand side is always negative. So you find, let's say you just label here 2 Let's simply put 2 here. This is to mark your Z-score. It's 2. And then the area more than means what? Remember the probability represented by the area below the curve. So more than means we have to shape this off right hand side. Okay? So what is the probability here? The only way to find out is look at your table just now. What's the value? 0.02275. Anyone look at the table just now? Now, let's say I go to the D, Z less than the negative Z. It's the same as Z more than the positive Z. What does that mean? Whether you are looking at the positive Z, more than means this side. Less than negative Z, you see the negative, so you have to look at the left side. So I put here negative. Now, the Z and the Z here is the same value one. Remember the symmetry? The only difference is one positive, one negative. Now, these two value is the same or not? Same. Why? Because it's symmetry. That's why I say here, the probability for the Z-score less than this, less than this, you shape this to your left hand side smaller. And then equal to the probability for Z more than means you shape to the right side of this Z-score value. Example. Okay, everyone. Find the probability Z less than negative 2.36. Can you draw this normal curve? Negative means left-hand side. So I put here negative 2.36 up. This is a value. So less than means you have to find the smaller place, not the bigger one, the smaller one. Can someone tell me what is this probability? 2.36. Don't look at the negative one. If you are very scared about the negative, the other way is, remember this one, this concept, you actually can write as what? B, Z more than positive 2.36 up for this one. Okay, so you can, if you're not sure this one, then you can look at the positive 2.36. This time positive up, then more than means you have to share this one. More than. So do you think these two values the same? Yes, symmetry. So can you look at the what's the value? 0.0 914. Anyone need help to find 914 here? We look at 2.36 0.36 0.0020, right? 914. Chen Yi, you miss 1 0, Chen Yi, 0.00914. Anyone need help? I repeat, anyone need help? I can show one time. Jolie means what? Jolie, you raise hand means you need to show. Okay, never I show one time. 2.36, where is positive or negative? So everybody go down to the table. So you look at the z-score 2, 2, and then 0.36. So you look at here, sorry, 2.3, 2.36. Then you look at what? 6 here. This one is 6.06, right? So 2.36 is here, 0.0094. Anyone cannot follow? Look at 2.3 and 6. Yes, the negative is just to tell you left hand side or positive is right hand side. As long as both sides are the same. I told you the negative positive just to tell you whether it's left or right. They are the same one. So later when you do tutorial question or whatever, you find the negative also can, you find the positive also can. If the question asks you right hand side, you do the right hand side. If the question negative, you do the left hand side. As long as your table measure outside up, not inside up. Okay, this is we give us to part E. I explain what's the meaning measure inside. Now, if I have a P example, Z more than negative 2.41, let's say. So let's say I use this converter negative, I have to draw negative up. 0.41 here. Everyone follow? Okay. Now, this time the question asks probability more than just now is what? Less than. Less than, so we measure to the left smaller, or you measure more than to the right. Both are the same. If this example say Z more than negative 2.41, this is your negative 2.41, everyone follow? Okay, can you tell me how much is this? The small one, shaded area. Remember our normal table is measured upside one, whether left or right, doesn't matter. How much? I think everybody should be able to read the table now, right? 2.41. So you don't see the negative, you see what? Let's see, because the z-score, they don't have negative one. Can you see what? The z-score here, no negative one. It is positive only. So we just look at 2.4, and this is 1, right? 0.00, sorry, here. 0.00798. Okay? So don't worry about the negative. 0.00798. So I just repeat here. This one, 0.00798. But what you want is more than. More than means what? The white color one or the shaded one? White color one, right? More than one. So what we want is this one. Not the shaded. Shaded is given by the table. So we have to take one. 1 minus, why 1? I told you the total is what? 1, right? Minus, like the shortcut formula. 1 minus the one that we don't want. That's the balance. It's the one we want. So you can write here 1 minus. Actually, you write 1 minus what? Is that more than? Or you can write here 1 minus pz equal to 2.41. If I don't want to confuse you, you just straight away write 1 minus 0.00798. Okay, calculator 0.202. Here, everyone. Okay, we go on now. Take z equal to 1. So 1 is here. This one is more exercise coming up. I hope no question. Anyone want to ask any more question from here? So don't worry about the negative positive. Just mark positive right side, negative left hand side. But when you read the table, there's only one z score. Just read the number only. Okay, then you must know whether you need to take 1 minus it or not. See which side you want. Okay, look at z equal to 1. So positive 1, right? So you label here 1, let's say. More than means you shift outside. Okay, can you check if this is 0.157? Anyone cannot follow? Yes, right? Okay, let's look at example next. Take z 2.77, positive, right? 2.77. Okay, more than means straight outside. How much? Is it this one? Yes or? If the question one the other way around, z less than 2.77, then what do you do? This is given outside mark. But if less than that, means you have to find this out. So you have to take 1 minus 0.0280. Simple as that. Sometimes the more easy, the more I worry. People can confuse very fast one. I don't know how. Difficult, don't know how to do. If easy, confused. So what else? Okay, let's do some exercise involve long story one. Okay, now listen carefully. The question usually given is non-standard. How we know non-standard? See, this is the lifetime of electrical component. Mean 2000. So you write down mean, and standard deviation is 200. So 200 you must put square. The definition is variance of sigma square, so 200 square. Some people they don't put square. Examiner always argue. Mark wrong, minus mark. Examiner like a minus mark. I say maybe whatever they say. No, minus mark. Cannot minus mark. So make sure you all know this is a standard deviation. Alright, so non-standard. So So we have to find the probability that the component will last more than 2200. Can we do one by one? So again, you let X defined as the lifetime of electrical component. This is your lifetime of the chip. So this is your normal. Okay, more than 2200, more than is bigger. So you can write as what? Remember, this is an X, is it? Because you define X as a lifetime. This is non-standard. So you cannot use the table until you change your standard. How we do that? Actually, here they jump one step up. Like, can I write here? Copy that. Actually, they jump one step. Now, this X to change to Z, your X must minus mean divided by sigma, right? No? This is your formula. No? Here. See? X change minus the mean, sorry, divided by sigma will become the Z. So actually, can you copy this step here? Before you jump to here, you copy here, then copy this one inside. So the left hand side, X minus mean divided by sigma more than. So your right hand side, you will do mathematics, right? If your left hand side you minus 3, your right hand side must minus 3. If your left hand side plus 6, your right hand side must plus 6. Right? So if your left hand side minus mean, then the 2002 also must minus mean 2000. If you divide by sigma, this one must divide by sigma, which is 200. So this will become your Z already. And then more than this one. So actually you skip one step. Can you copy this one here? And you continue here. So 2002 minus 2200 divided by 200 is 1. Okay, positive 1, right? Just now. More than. Anyone don't understand? So you know how to change to standard already. That's why I say, out of 10 questions you do, past year, 9 questions non-standard one. Straight away you have to learn how to change to standards. Less than 1008. Less than means smaller 1008. So I go quickly now. So change your standard. Left hand side minus 2000 divided by 200. Your right hand side 1008 also to minus 2000 divided by 200. This one becomes Z. This one becomes negative 1, right? Less than minus 1. Where do you shape? Smaller. That's why, right? Is it the same as more than 1? That's why I mentioned symmetry, right? If you don't want to write this down, you didn't know how to look at this one, right? Offside, less than minus 1 should be same as 0.15. A7 should be same as more than 1. Learn the symmetry fast. Don't worry about the negative in your table. Table don't have negative one. Just to show you left hand side or right hand side. Okay? Quickly learn out everybody. I hope you can understand the concept fast. Yes, positive one is 1. Yeah, positive is 1 is 1. Okay, positive is 1.
No. What I mean is that after X change to Z, right? The mean becomes 1. I mean like the standard one that you explained just now.
Oh, you mean, yeah. The X will become Z, become standard already. Is this your question?
No, what I mean is after change to Z, the mean becomes 1, right?
Negative. This is negative. Are you talking about A or B?
I'm not exactly asking for A or B. I'm asking in general.
No, this one, the value here, you have to calculate from here. the value minus the mean divided by standard deviation. You see or not? You see how you look at the C1, 1009 minus 2000 divided by 200. The value here can change one. What important thing is the x must change to z standard. Then this value you calculate. Chingy, have I answered you?
Not really. I get the part that you're trying to explain, but then
Well, you write positive 1 or equal to 1.
no. The positive one is actually a mistake.
So?
Yeah, what I'm trying to ask is after x changed to z score already, the mean is the mean is zero.
Oh, you're asking mean will become 1. Yes, sir.
So mean is 1 or 0.
Also, mean is 0. Standard deviation is 1. See, everyone, remember I told you x, the mean is not 0, right? Standard deviation is not 1 now. Your x is this one, right? Right, remember? 2000 and 200. But once you change to standard z, right? This automatically, your mean become what? 0. And standard deviation become 1 already, 1. No need to think already. Chingy? Everyone?
Okay, thank you, sir.
Okay, so mean is 0, standard deviation is 1. Alright, the next one, 1009 minus 2000 divided by 200 is negative 0.5. So this one actually you can mark as negative 0.5. Then more than means what? First thing you have to find here, because your table gives you outside 0.3085. But what you want is more than the negative side. So this one you have to find. So you take 1 minus 0.305, you get 6915. Okay. So the equal sign, you don't put also the one. 3 is alright, it's continuous. Okay, one more. Less than 2001. Not more than means less than 2001 are equal. So you can put equal sign there, not more than. So minus 2000 divided by 200 is positive 0.5. This is positive, everyone. Positive. So they want the less than. They want this. Careful. But our table is giving you offset 1. Can you tell me how much it is? This one is 0.3085 area. This is what given. But what you want is less than this one. So you have to take 1 minus same thing. Anyone still cannot follow? Your inequalities more than less than shaded outside to the left or to the right. Okay, next E. Between, if you have between 1008 and 2002, this question involves between. So how do you write? Between 1008 and 2002. So no chance, now you got left and right, two-sided. So same thing, your x will become standardized really. So your left and right both have the minus mean divided by standard deviation. Accordingly, just minus and divide. So you get minus 1 and 1, right? One positive 1 and this one negative 1. So if I ask you to label this, positive 1 is here, negative 1 is here. Between is what? Here, right? What you want is between minus 1 and 1. But the table gives you again the outside 1 is how much? 0.157. This one also same one. Symmetry. So what we don't want is the outside 1, right? The shaded. What we want is between minus 1 and 1. So you don't know how to write this diagonal 1. Some people ask, how to write this? Tell them, you don't know how to write this diagonal. What important is to look at your normal curve. We want the white color one. We don't want the shaded one. So what do? You take the whole thing is 1, right? Then what do? Minus the one you don't want. Then you get the one that you want. So minus 0.157 and minus 0.157. That's why you see 2 times 1. Same, so you just times 2, then you take 1 minus it. Anyone don't get it? This is for one side positive, one side negative. How about those both sides also positive, both sides also negative one? Possible? Okay, before I go on, any questions? I hope nobody confused. After this digest. Okay, can we go to between 2001 and 2003? So 2001 and 2003, same thing, left and right, change to minus 2000 divided by 200 is 0.5 positive, 2003 minus 2000 divided by 200, 1.5. So this is your Z score. Now I see both also positive, 0.5 and positive 1.5. Remember, the bigger value means to the right, like your x-axis start 1, 2, 3, 4, 5. So between this one and 0.5, 1.5, if you again don't know how to which one minus which one, then you don't see you know how to write better. Then you can try to go from here. But what you want is, based on picture, you want this, right? So, if you want to really understand what this means, this one is Z more than 0.5. Can I ask you all, which probability is higher, 0.5 or 1.5? How you know which one is bigger? You look at the shaded region. 0.5 from here to here is bigger. So can you tell me this probability here? How should I write? Maybe you want to draw. Then it will be more things to do. So never mind, you just think of 0.5 here. What's the probability for 0.5? 0.305, right? You have to minus out. See, you take this one whole thing, you minus out this one, 1.5. 1.5 is it 0.0668? The bigger one, which is 0.305, minus the smaller one. Both also measure outside now. Both also measure outside. 0.305 minus the 0.0668. So this, the black color one, is between 0.5 and 1.5. This is 0. Must know which one minus which one, because both also positive. Unless this one, one negative, one positive, then you have to take one now. This one you cannot take one minus, no? Unless they want the right hand side, the left hand side one, and then you take one minus it. Because both also at the right side. So you take the bigger one minus the smaller area. Any questions from anyone? So now you practice how to use see the curve. Then you use the normal probability. Yeah, then you see which one minus which one. Okay, one more. G and H, 1007 and 1009. This one should be both also negative. So negative 0.5 should be here. Negative 1.5 should be here. So again, this should be the bigger probability minus the smaller one, like just now, 0.2417, between negative 0.5 and 1.5 negative. It's a symmetry, yeah. And the last one between 2000 and 2004. So this one you change to the score. We have 200. So 0 divided by 200 is 0. And then this one you have Z is 2. So between 0 and 2, this is the area you want. But again, from 0 to here is 0.5, right? Remember? Half mark. Then you minus out this one. Because what we want is between 0 and 2. So from 2, offset 1, how much? 0.02275, right? Everybody check out. So half minus this, then you get the balance is between 0 and 2. Okay, so any of you need help? Which part? 1, 2, 3, 4, 5. A, B, C, D, or to H. Which part you need to repeat again? Just practice a few more rounds. Make sure you memorize with the reading. Okay, which one positive, which one negative, which area of the probability the question 1. Okay. Now we take a quick 5 minutes break. Then we come back. We will have to do another type of questions. This is also important. Okay. Now in the beginning, we learn how to find the probability given by the Z-score between certain area. It could be one positive, one negative. It could be both positive. It could be area between both also negative. Right? So what we do is just change the X to Z-score. Now, after the break, we are going to look at certain questions which you have to find. You are given the probability. You have to find back the Z-score. So far, you have seen all this example. They give us the Z-score, right? You see all the Z-score here. You find the probability. Try not use the normal table, which they give you the shaded offset one. So after the break, we do question in both the other way. They give us the probability. You find back the Z-score. Okay, we take a 5 minutes break now.